Everyone, my name is Sharon Platt, and this video is going to be about atoms and their subparticles and a little bit about the periodic table. So I'm going to talk about atoms, and I have drawn this little atom here with its particles. Now, one thing I want to say right off the bat is this is not proportionally correct. I was reading today something that said that if you took an atom and made it the size of a stadium, that the nucleus here in the middle would be the size of a pencil eraser in the middle of the field, and that the electrons outside here would be like little gnats flying around the outside of the stadium. So atoms have a huge amount of space in them, in spite of them being so incredibly tiny. But just know that this is not proportionally correct. We draw it this way because it's easy to see what's going on. All right? So, atoms are made up of three particles. We have our protons, which I did in red, our neutrons, which are the blue dots in the middle there, and electrons, which go around the outside. So our protons and neutrons are in the nucleus, and then the electrons run around the outside here. Something else is that protons are positively charged, electrons are negatively charged, and neutrons have no charge. They are neutral. And this is how the atom holds itself together. Think of like magnets. You've got two magnets, and if you put them close together, they stick together. So your positive and negative charges are like that. They hold themselves together. And that's why the atom doesn't just fly off in all different pieces. All right? Another thing, this here where the electrons go around is called a shell. And this is one way to describe it and draw it, and that's how I will do it here and in these videos. But you should know that there are things called orbitals. Electrons don't follow this nice, neat little circle. That's not how nature works. There actually are other ways, more intricate ways that they behave. But for purposes of our videos, we're just going to do these shells and pretend that they follow nice, orderly little round paths. All right. This shell, this innermost shell, which on this is also the outermost shell, holds only 2 electrons. So you can have 1 or 2, but the maximum it will hold is 2 electrons. The other shells on other elements, other atoms, there can be 2, 3, 4, even 5 shells on atoms, and each of those will hold up to 8 atoms, or 8 electrons. So the innermost shell holds 2, all the others hold up to 8, and the outermost shell, no matter how many shells you have, whichever one is the outermost, is called the valence shell. And this will become important later when we talk about bonding. So this valence shell, which is also the innermost and outermost, is full. It has 2 electrons in it, so this one is happy. They like to be full. If your valence shell it can have up to 8, it is happiest when it has the full 8 in it. All right? So that's the basic structure of the atom. And then let's talk about a little bit about this little way of writing things. So if you'll notice, I had that up here because this atom is helium. All right, so this He stands for helium. Every element in the periodic table has a 1 or 2 letter abbreviation that we use, so we don't have to write out the whole thing. And when we're writing important numbers down, we use a subscript and superscript with it. There's another way to write it. I'll show you in a minute. So this subscript is called the atomic number. This is the number of protons in that particular element. All right? So in this case, helium has 2 protons, as we saw in here. And the top number is the atomic mass, and that is the number of protons and neutrons, the mass that they take up. Now, on Earth, we tend to think of mass as weight, That's not technically correct. If you have the same amount of mass in outer space, it does not weigh the same as it would on Earth. So weight and mass are not the same. But it helps me to think of it, at least on Earth, as something related to weight. So our helium weighs 4. But that is not technically correct. So if you are a scientist, you will not want to use it that way. All right, so let me show you the other way of writing these. And I'm going to try to hold the book still. So this little yellow square, you can see it's also helium. You have the He, and you'll see in this case the 2 is on top of the He. That is still the atomic number. And the mass number is down below, 4.003. Okay? It's just a different way of writing it. That's how it's written in the periodic table itself. Same numbers, just different positioning. Sometimes it's easier to write it this way, sometimes it's easier to write it the other way. So something else about these, if you decide to change the number of protons, you will actually change the element itself. The protons define the element. Helium always has 2 protons. Neon always has 10 protons. Oxygen always has 8 protons. All right? The proton defines the element. You can't change this without changing the element itself. So these are always going to stay the same, except in very rare instances, which we'll maybe talk about later. So neutrons, if you change those, usually it's more, not less, but if you change the number of neutrons, you get an isotope. And we will talk more about those later. I'm not going to go into it now, but just know that if you change the number of neutrons, you get an isotope. If you change the number of electrons, you get an ion. So remember, we have all those electrons going around those shells. If one electron goes somewhere else, maybe it binds to another element, another atom, you still have the same number of protons, but you now have less negative particles. So you're going to have a positive charge, and that's called a cation. And that is a positive charge. If you add another electron, so you're adding some negative, you still have the same number of protons, so now you're going to have a negative charge because you brought more negative into it, and that is an anion. I like to think of it, the cation has a plus in the middle, the T, and so that's the positive charge. The anion is the negative charge. All right? Now I would like to show you something in this book, and this is a portion of the periodic table that they've kind of scrunched together. But I love this. You won't have this in your book probably because this is a different book, but I love this chart because it makes it so clear. So we're going to look at this and then we'll look at the regular periodic table. So over here we have hydrogen, and that has 1 electron. You see the 1 electron in the shell there? And it also has 1 proton in the nucleus. They just show the nucleus. They don't show how many other than by the atomic number. And over here we have helium, and it has the 2 electrons and 2 protons. And then if we come back over here, lithium has 3 electrons and 3 protons. This one has 4, 5, 6, 7, 8, 9, 10. There's our neon. Okay? So in the periodic table, as we go this way, they call them periods. So the rows are called periods. And as you go across there, you add an electron, add a proton, each new element. And then the columns are called groups. Now let's take a look at the hydrogen and the helium. You'll see they both have 1 shell, right? The next period, the next row, they all have 2 shells. The next row, they all have 3 shells. All right? So this is how the periodic table was built. So that's the periods. Now take a look here on the columns or the groups. Look at the valence shell only. How many electrons are in just the valence shell? In this column, or in this column, there's only one. In this column, there's 2, 3, 4, 5, all the way across to 8. All right? So that is also how the periodic table is built. That's why it has spaces, and that's why it has other stuff in it. All right? But those are very important things to know, and we'll talk more about them later. So here's the full periodic table. And if you'll notice, the hydrogen is a different color. That's because it actually goes over here, but it fits in the table here because it has a 1. So again, you have your periods going this way, your groups going this way, and there's one thing I want to show you. You've got, okay, so all these guys have 1 in the valence shell, all these guys have 2 in the valence shell. These guys in the middle are a little different, so we're going to skip over those. These guys have 3 in the valence shell, 4, 5, 6, 7, 8, okay? And, well, except for helium, which only has 2. But over here, all the valence shells are completely full. Everything in this column. These are called the noble gases because they don't combine with other things. They don't like to bond. They're already happy. Their valence shell is full. They don't need to bond with anything. So that's why they're called the noble gases. They stand alone. All right? These guys over here that only have 1 electron in their valence shell, they love to bond with other things. All right? Or these guys here that have 7 in their valence shell, they dearly love to have another 1 to fill that valence shell. All right? So we'll talk about that more in another video, but I wanted to give you an idea of what's going on here. Also, these blue and green things, these are all metals. All of those, most of this chart is metals. Now the hydrogen is not. The hydrogen actually goes over here for this purpose. These yellow guys here, these are metalloids. They have some characteristics of metal, but they're not totally metal. And all the others, the peach and pink ones, including the hydrogen, those are non-metals. And that's going to become important when we talk about bonding as well. All right? So that is the periodic table. Have a good day.